All right, everybody who survived the break. I don't know what the hell's going on out there. Oh yeah, by the way, Mr. Lars, zombies. Alright. I'm very relaxed. I like that. People? Alright. I don't know. Somebody's check them out if they've been bitten. So let me start with a really, really nice one. Okay, here's the nicest freaking one in the world. Alright, so that one, so solving to do there, right? What's X? 2. You with me? Alright, now, just to kind of build it up to when it gets more complicated, how can I rewrite 9, 3 to the... And of course, a lot of you guys are like, well, that's why I knew it was 2, yeah? But now look, the bases are already equal. So in order for this to be true, X has to be 2. Bam. So that kind of informs us of what to do. If I have a problem like this, why can I do this problem in sort of the same way? You can do it, Jeff. Sure. You can't do it exactly the same way. This was easy because 3 to the power is 9. That was easy. Here, it's not quite as straightforward, but I can still do what I just did here, can't I? What can I base them both off of? 2. Good. You guys understood what I mean. I can base these both off of 3. That already is freaking 3, and that's 3 squared. So this is 2, 8. Now watch this. I'm going to rewrite 8. So I'm going to have the X just sitting there waiting. I can rewrite 8 as 2 to the 3rd, and I can rewrite 4 as 2 to the... That's crazy. And what do I do here? Yeah, so I get 2 to the 3x equals 2 squared. All right, let me stop there for a second. I really want you guys... It's almost too easy to believe. The bases are the same, so the only thing I have to make true for this equation to be true is for the exponents to be equal to each other. So 3x has to equal 2, so x has to be 2/3. All right, let that soak in. You guys can imagine that this is going to be maybe the first 5 questions, if you're lucky. Because what can I immediately... If I would have made this 5... This goes to hell. Yeah. So that's the next thing we're going to do. But if I have numbers that can write with the same base, you could do it this way. Cool. I like it. So you guys try this one. What do you got, Jeff? Let's see. Yeah, let's not make it too freaky, Jeff.
Yeah, not yet.
Three 27s multiply make 81. Trust the process. The process is that.
So 27 is 3 to the 3rd.
What can I base both of these off of? 3. You guys see that? They're both powers of 3, aren't they? We should know these numbers by now. 27 is 3 to the 3rd, so that'll be 3 to the 3x. 81 is 3 to the 4th. Yes, sir.
Why didn't we get rid of the x now? Real quick.
I didn't get rid of the x. How do you mean?
Yeah, why didn't you take away the 0? Because if you added it, or you put the 3 there, it just adds.
All right. And make sure you really understand what's happening. I'm going to rewrite 27. Anytime in the universe I see the number 27, I could instead write 3 cubed. Because it is 27. But what's still there, I rewrote 27 as this.
Okay.
And what's happening to 27? Being raised to the x power. So it better still be raised to the x power. But now these can multiply. And if you can make the bases the same, you can focus on the exponents then.
We're just working backwards.
What do you multiply 4?
Three to the fourth is 81. He just rewrote it.
Oh, okay.
Oh yeah, so 81 is 3 to the 4th.
Okay, I thought it was still.
So since I can base them both off of a base of 3, I mean, sometimes consider the word base, then that allows me to do the equation like this, a nice, beautiful, but I can't always do that. So we need some other property, some other way to do this. All right. So what if it was this here? Well, before we leave this, let me give you one. Let's see. What do you think about this here? Sure, I like it. Yes, sir.
For the 81, actually, how come you couldn't just do 9 and 2? For like, or 9 to the power of 2?
Oh, because then the bases would not have been the same. Why was I allowed to go
Yeah,
from
you
there
need
to
to
there?
do
Because the
okay.
bases were the same. Yeah.
Okay.
Yeah, and I can't base 27 off of 9, so I don't. Yeah. So don't say it out loud. Try to do that one. It works the exact same way.
Should we make the base 5 or 25?
Sure, Leo just said make the base 5. Sounds like a good idea. Don't say anything else. I mean, hopefully that's obvious, right? I mean, we should know the one number 125 and how it relates to 5. So do it. And if I'm you, I'm like, yeah, of course you give us one that's harder than the ones you showed us, you math person. It's not that much harder.
So we're doing, so 5 is their number?
Yeah, 5 is the number you want to base everything off of. I like it. I don't know yet. Sounds about right. You said 7/3? Yeah. All right, let me catch up to you guys. I'm going to rewrite 125. I'm going to have an x minus 1 just sitting out here. So 125 is 5 to the 3rd. I'm going to have a 2 sitting out there. 25 is 5 to the 2nd. So all I did is rewrote 125. There's still an x minus 1 on it. I rewrote 25. There's still a 2 on it. And now I can simply, what do I do here? Good. Minus 3. Bam, bam. Now, since you were able to make the bases the same, you can focus your attention on the powers. And to be honest, let me show you what we actually did to get from here to here. What did I do to both sides? I did log base 5 to both sides. Do you see that? Because what would that do? Wouldn't that kill that? And that would kill that. That's technically what I did to both sides to go from here to here. But it's perfectly fine to say, I got the bases the same, now I got to make the powers the same. See, that ends up in the same place. It's a conceptual way of thinking about what we did. Yes?
I was curious because from the 125 power of x minus 1 and then the 25 power of 2, what I did was I already just did the x minus 1 equals 2. And went from
Oh, well, why would that have to be true? If I had 4 to the x equals 4 to the 7th, why must x be 7?
because the power, one side of the x and the other one is...
Well, because these are the same already. So you only have to make the powers the same in order for the equation to be true. Are the bases the same here?
No.
No. So if the problem was 2 to the x equals 4 to the 7, can you say x equals 7? No, because then it would be 2 to the 7. Is that the same thing as 4 to the... No, it's not. So the bases have to be the same in order to take that step. And that's another way to look at it. If the bases weren't the same, I couldn't do the same thing to both sides, which I must do. Right? If then I make the bases 5, then I can do log 5 to both sides. Same thing. So this becomes what x equals 7/3. Cool. All right. So that's one kind of level of equation. Now what's going to happen more often is you're not going to be able to do that. Ah, shit. So a problem like, and this is why I said, I don't know if you guys remember, the most important property of logarithms and exponentials is that logarithms take powers down. So we're about to figure out why I said that. Was I insane? Well, that's a separate issue. So like if I had 7 to the x equals 125. You sure you meant 7, Jeff? No, yes, I meant 7. It's too bad for you. Can somebody tell me what the number has to be between? What's the answer going to be between?
2 and 3.
2 and 3. 7 squared is 49. 7 cubed is is more than that. 343. So it's got to be between 2 and 3 to come out to 125. Do you have to know that to be able to do this problem? No. But you know. So what the hell? Shit. What the hell? Have you noticed something evil about your calculator? What kind of logarithms do you have access to on your calculator? Can you do log base 7? Has anybody looked to see if they could? Can you do log base 7?
No.
No, you can't. What's the only logarithms that are on there?
10.
Log base 10 and
8.
log base E, ln. Don't say log base E. You guys you understand what's happening? So this kind of problem, in order to do it, I know the answer is going to be gross. I have to be able to use the calculator eventually. So what log? I don't want to do. I could do log base 7. Why would that make sense?
Because then you could.
Because it is base 7, right? But why doesn't that make sense if I want you to estimate the answer? Can you do log base 7 in your calculator?
Yes.
Can you?
Yeah, under math.
Yeah, shit. I was hoping nobody would.
Log base 7 over 10.
All right. We're going to pretend like we can't.
Or you.
I was waiting to see if somebody would actually look. I mean, that's where we can do any root. So that's a good place to see if you do any log.
Do you do 7 over 10 log?
So here's what we do. You ready? I want to use either log or ln for this. You used to not be able to do this. Why? Because on the face of my calculator it says log and ln, right? Math people, we normally use ln because it's one less letter to write. So here's the idea. I really want this to make sense. If I take ln of both sides, it's the same exact thing. How would you solve this to get the real answer? You would take the cube root of both sides, right? Or how would you solve this? You would do what to both sides? Put both sides inside of a square, right? So you can take the square of both sides. So what am I going to do to have this? Why am I doing this? That was a good way to introduce this, Jeff. Why am I doing this? Because where's my variable? In the exponent. What's the only thing in the universe that could take an exponent and bring it down? A log. That's the only thing that has that power, right? And so what can I do with this x now? I can put it out front. So I get x times ln of 7 equals ln 125. And now what can I do to both sides? What is ln of 7? I don't know, but it is a what? What's the square root of 11? Gross, but it is a gross number. So x times number equals number. How do I get x by itself? Divide by this number. It's exactly like I have 5x equals something. How do I solve for x? I divide by 5. So I divide by the number that's there that I don't want. Right? Like I always do. Dear God, you cannot divide by ln. It doesn't make any damn sense. It's like if I said solve this and somebody said, okay, let me divide by the square root sign. So x equals 4 divided by square root sign. Next. This math is easy, Jeff. Isn't that? So square root sign doesn't mean a damn thing unless something's actually in it. ln doesn't mean a damn thing unless something is actually in it. Good. Because this happens so often. You can't divide by logs by themselves. You have to divide by log of something. Now it makes sense. That goes away. So x equals whatever the hell this shit is. And then so you can
2.48.
2.48,
1.
blah, blah, blah. Okay. And that jives with what we said earlier. We said it should be between 2 and 3. Because 7 squared is 49, 7 cubed is 343. So it should be between those two to come out to be between those. Yes.
So you could have just written x equals 125 over 7.
No. I could have done this. Now that somebody's given away, I don't blame you. I threw the question out there, didn't I? From the beginning, I could have done this with this problem. I could take the log base 7 of both sides. And that makes the most sense because the base is 7. So what happens if I take log base 7 of both sides? What happens here? So I get x equals right, and then if you hit your math button, you can actually, there is a button for any log of base, yeah. I'll let you guys figure out how to use it. If you can't, you can do it that way. Yes?
Why were you able to do the natural logarithm?
Every log has the property that if the inside's to a power, it can come down. So I could use any log I want to. Back in the day, they didn't have the log anything button. They only had log and ln. I like it. So what we normally use in math is we just use ln. Because, like I said, it's exactly because of this. One less letter to write than log. Yes?
So whenever there's like a number or something in front of log, would be natural log?
You can multiply by anything on each side.
No, I can take any log I want to. Why would I do ln? Because it's one of the two logs that are on the face of my calculator. I don't have to dig for it in some other list. Do you see what I'm saying? So I could have done log of, what was that? I could have did log of both sides.
And you get the same answer.
I get the exact same answer. I like it. So real quick, is everybody able to recreate this answer in their calculator if you have one? Everybody got that okay? Because you have to be careful with the parenthesis that opens. So what I'm saying is, that's the same as this. Because if I would have taken logs of both sides, it would have been log, and now try that. Do that in your calculator. If it don't come out to be 2.48, then I must quit. Right? If the answer don't fit, I must quit. Well, that's a throwback. Yeah. It's the same, thank God. All right. It's got to be the same. It's got to be the same. Because I can use any log I want to here, and the reason we use one of these two is it's the easiest log button to get to. It's right on the face of my calculator.
Why are the two? Why is there log and then ln?
Why do they put that in the face of the calculator? Because those are the most used ones. ln is because all of my exponential growth, which involves any growth of bacteria in a petri dish and all this kind of stuff, that's the most used one in biology sciences. So they had to put the ln there, right? Because that's related to the e, which is the most used base. And then log 10, base 10 is the most used log for Richter scale and decibels and all this other stuff. So those two logs are the most used logs. Now what roots do they have specifically? On the face of it, they have square root. It's the most freaking used root. And then what do they have under math? Cube root. That's the second most used root. And then they have any root after that. So they put the most used things in the most accessible place. Cool. I like it. The most important thing to get from everything that just happened is, if my variable is stuck up there, a log is the only thing that can bring it down. I like it. So, remember this. What did we do? Let me just jar you guys a little bit. What did we do with a problem like this?
You get like denominators.
Like denominators, and then we kill them by multiplying. There it is. Why did I multiply? Because where are my variables stuck? In the denominator. So how do you free them from there? You multiply by them, right? So where is my variable stuck? In the exponents. What's the only thing that can free it from there?
Division?
Logs.
No.
Division don't do shit for you. Logs takes that down. So be careful. I mean, what's 7 to the x divided by 7? Oh, I like that question. Ooh.
1 to the x?
Nope.
7 to the x over 7?
7x minus 1.
Yes. Math doesn't give a shit what's there. What do I do when I divide like bases? Subtract the powers. Why don't the 7s cancel? Because how many 7s are on the bottom? How many 7s are on the top? Possibly a billion. So 1 7 can't cancel a billion other 7s, right? I like it. But when I divide by a 7, I lose a 7, don't I? Isn't that what that says? I had x of them. I divided 1. Oh, I lost 1. Shit. So now I have x minus 1 of them. All right, all right. That's what I keep trying to get you guys to realize. Any process you learn will never change. Right? When you subtract powers, okay, I'll always subtract powers if the bases are the same and divide. Always, 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 always. All right. So, let's go to the next level here. What about this thing? I don't know what Roman numeral I'm on, so I'll start over. All right, let's do this one together. It's a little bit gross. What's different here? What's worse? Well, don't worry about that. It's just the number.
Variable on both sides.
Variable on both sides. Big X. That's what's worse. Now I have, they're both stuck in the freaking exponent, but I still take care of the problem the same way. And here's a really good reason why, I mean, this is beautiful. I didn't even think ahead far with concern about the fact there's a log button. What log base would you use here? You're screwed. You have 2 bases. So, it's too bad. So I'm going to take the what of both sides. You can do it. I'm going to take the what of both sides. What's going to make, yes, I'm going to take the ln of both sides. I could use any log I want to. But again, I'm going to use the one that's on my calculator. That's easy to get to, right? And it has one, I could take log, but I do ln. That's what you almost always do. And yes, it is because we're lazy math people. Or efficient with our time. If you want to be kind. So here's where people aren't careful with parentheses. What can I do with this?
Bring it in front.
Bring it in front, and if I write it like this, I am so wrong.
Isn't that be 1 ln?
Yeah, it's got to be that times what it came down off of, right? Equals. Now, please, dear God, please, dear God. Remember, what's ln of 438?
X.
It is a
Number.
number. I like it. It's a number. That's all it is. Don't put here what it is. I'd much rather keep this here because that's the exact answer. If you put a decimal, you're automatically wrong. I really want you to understand that because you have to round because that decimal would never end. So leave that. You got to get used to playing with this shit. How would you solve this if you saw this equation? I know it's written weird, but I'm going to write it the same way we got that. See how it's written kind of backwards, but I don't care. How would you solve that?
Distribute.
Yeah, you would distribute. I would write that in the front, right? Get my x's on one. Okay, I'm going to do the exact same thing here. I'm going to distribute that number. So I'm going to get x times this minus that, I like it, equals x times this. The reason I put the x out front is if I write this, is that ln of 5x or ln of 5 times x? Which one? I don't know. So if you mean that right like that, it's easier to tell that ln of 5 is multiplying x. X is not inside the ln. That's why I put the x in front. All right. So now what's the next step? Same next step you had over there. Yeah, I need all my x stuff on one side. My coefficients are gross, but the process doesn't give a shit. We kind of care because we're the humans.
How come there's 2 ln 11.2s?
Because right here, why are there 2 2's?
Oh, we distributed it?
Yeah.
Oh, you do 20. That's okay.
Yeah, that is a number like 2, 5, 7. So it gets distributed, right? you got to be okay with writing that. It's not a big deal. You're going to write a number there, and that's what the number is. So now are my x's together? No. So that's telling me what to do next. I can move that over, right? Let me get rid of that so you don't think it's division.
Why are you able to subtract? I thought they're together by multiplication.
What would you do next year?
Get all the x's on one side.
You would subtract what?
Or
What would you subtract? How would you get both x's on one side?
it's 2x. Okay.
Okay, all right. I'm moving the whole damn thing. I couldn't, like here, if I subtracted 2 and I said the answer was x, that's a problem, right?
Yeah.
That's somebody thinking that subtraction can kill multiplication. So that's sort of like what you're worried. I'm moving the whole damn thing over. I can do that all day. It's positive this, I do minus it, it's gone on that side. So on this side I get negative ln. Jeff, you could do it. Negative LL? No. That's a llama natural log. Yama. So, yeah, I get.
ln 438 minus
You could do it, Jeff.
ln 2. And then you can turn into division.
So remember, anytime there's more than one variable, there isn't. I can take an x out. Whew. When is this problem over, John? Yes.
Are you gonna now distribute the x through out there?
That would take me right back to where I was. I'm one step away from having x by itself. What do I want to get rid of? Why is x not by itself? It is doing what to what? Multiplying this shit. What do I want to get rid of? That shit.
So just multiply both sides.
Divide by that, yeah. So it's just like over here. What would I do next? Subtract 2x, negative 2 equals 3x. X is not by itself because of the stupid 3, so I divide by the stupid 3. X is not by itself because of the stupid so I divide by
Over x ln 426.8.
Oh, be careful now. Come on now. Can you combine these? No. Why not? Because you can't. What's this? What's the square root of 438 minus the square root of 11.2? You can't do that, right? They're not like terms. So are these like terms? Hell no.
I thought they would be.
But why?
I'm just.
So again, when I see, if I saw this, you could do it, Jeff. If I saw this, that's not the same, that makes no sense. What I just drew up there makes no sense.
But if you had
So I can't like undistribute the ln. That is, this whole thing, please dear God understand, don't even write this down. This is bullshit.
yeah, but if you
Because the ln is not distributing, so you can't like undistribute it.
isn't it if you had the ln 438 over 11.2, doesn't that go and like convert back to that?
Well, then, yeah, you could. So you could, if you wanted to, you could rewrite this using a property of logs.
Right. Okay, that's what I.
Yeah, if you wanted to, but you don't really have to.
Okay.
Yeah, it just makes it look worse, actually. You got fractions inside fractions, yeah. All right, hold on. So, I mean, that's the answer, believe it or not.
So
Those
would
negative.
that cancel out and then that be on the left side would be
Yeah, kabam. So then I have the answer. X is... Negative.
11.2 over.
I keep wanting to put two
438.
L's.
ln 438 minus.
All right, a little unsatisfactory, but you can put this in the calculator. Negative 11, ln 11.2 divided by that. You can see what. Can somebody help me out? What would that be approximately equal to? Put that in the calculator. Calculator.
Well, you could leave it like that if you wanted to.
So you can,
Could you leave it like that, or would you have to put
totally. This is what I call. This is not just what I call, but this is the exact answer. Any decimal you give me will be an approximation. I don't care if you take it out 18 billion places, you're still wrong. It's an approximation.
Negative .659.
Is that what somebody else got?
I got .6115.
All right, let's see. I got dissension in the ranks, so let me see what I get real quick while this thing is warming up.
You got something else?
Be careful with all these parentheses. Yeah, I get that. So whatever mistake he made, I made the same mistake. Namely, none. All right, don't look at me.
How did you put it in?
All right, you ready? Here we go.
Yeah, I can get right.
So I'm going to do negative, right? Negative ln. See how it opens a parenthesis even on the new ones? It's like Microsoft Word. Let me guess what you're trying to go away, Microsoft Word. Stop. Nobody else feels that way? 11.2. That's negative 11. And now I've got to close a parenthesis.